Yes, this is the video for section 3.3, finding the derivatives of trigonometric functions, or simply trig functions. Okay, these are learning objectives. At the end, you should be able to find the derivatives of the basic trig functions, sine, cosine, tangent, cotangent, cosecant, and secant. Okay, and then we will look at the inverse functions later on. 3.5, 3.6, one of them, and then apply what you learn to solve our applications. All right. So let's start with one function, just the sine function, how we use the definition that we learned in chapter 2 to find the derivative of that. And I'll leave the cosine for you to prove it. Okay. And then the tangent, I also do the tangent, and the rest, I'll give them to you and you should know them. All right. Okay. So consider the sine function f of x is equal to that. Now, there are two trig identities, okay, that we'll employ, trig identities, okay, that if you have sum of, okay, the sine of two functions a plus b, this is what? Sine what? A, and then cosine b plus sine b, or cosine A, and then what? Cosine A, and then what? Sine what? Sine B. Okay, so this is what we have. And then the other one is a sine of A minus B. It's the same thing except that the sign between the two terms is what? Negative this time. So you get sine A cosine B minus cosine of what? The angle A times the sine of what? B. Because these are two trig identities that I want you to remember. Now, if you don't remember, check appendix what? Appendix D in the textbook. Okay. So remember the definition of a trig function. That is, let's write it here so that you can remember that if you want to find f prime of x in section 2.8, it said the limits h goes towards 0 of what? F of x plus h minus f of x, all divided by what? H. So we're going to use the definition, okay, to find the derivative of what? The sine function. All right. So let us apply them. My f of x is this. So what is my f prime of x? Okay. F of prime of x is what? The limit h goes towards 0 of the sine x plus h minus the sine of what? Sine of x divided by what? H. Okay. So we're going to use the first one, this identity, to expand the first term in the numerator as this. So this is equal to the limit h goes towards 0, and then have sine x, okay, cosine of what? Cosine of h, then plus cosine of x times sine of h, then minus the sine of what? X, all divided by what? All divided by h. Now notice that sine x, okay, sine x and then cosine x don't depend on what? H. Okay, so we can consider them as a constant in this case and pull them out. But as we can see, this is the same as the limits. H goes to 0. Let's bring the signs together. You get sine what? X cosine h minus sine x, then plus cosine of x times sine what? H, all divided by what? H. So this will give us the limit, okay, h goes to what? 0, and then we have what? The limit, okay, if you look at this one, you have the limit what do you call it, sine x times cosine of h minus 1 over h, then plus the limits h goes to 0 of what? Cosine of x, then sine of h over h. Okay, so we'll go to the next. Let me write this again here. So I can bring the sine x and the cosine x out because those two terms don't depend on h. So we can write this as what? Sine x times the limit h goes towards 0 times cosine of h minus 1 divided by h, then plus the cosine of x times the limits h goes to 0 of what? Sine h over what? Over h. Okay, so let's go to the next space so that I get more space there, right? So let's rewrite what we just wrote. We said that the f prime of x, okay, is what? The sine of x times the limits h goes towards 0 of cosine of h minus 1 over h, then plus cosine of x times the limits h, it goes to 0 of what? The sine h over what? Over h. Now, this is the same step that the last step that I wrote in the previous slide. So the question is that what is this guy? What is that equal? And what is that also equal? Okay, we're going to use some definitions. Okay, that can be proven. The definitions on page in your textbook, that is 191. Okay, or if you want to say that it is what, 80, page 86, using the what, Gersh method. Okay, the following, I mean, what do you call it, definitions is true. Okay, that is, if you have the limits, a certain angle theta, let's write it again, the limits theta goes to a 0 of sine of the angle, okay, divided by the same angle. Okay, this is equal to 1. And also you have the limits, the angle goes to 0 of cosine of the angle minus 1 over the angle, the theta, in this case is the angle theta, is equal to 0. So that means that if we go back to this proof here, it means that the limits h goes to 0 of cosine of h minus 1 over h is equal to 0. And then we have the limits h goes towards 0 of what? Sine h over h is also equal to 1. So if you substitute this into this expression here, you have for your f prime, which is a sine function, is equal to a sine x times 0 plus cosine of x times 1. And that gives us what? Cosine of x. So if I have the what? If my f prime of x, if the f of x is sine, so when you differentiate the f of x with the sine, you get what? Cosine of what? Cosine of x. Okay, so this is how we get the cosine of this. Now, in this section, this property in particular, remember I mentioned it in chapter 2. That's very important. You're going to see it again, and you'll see it in calculus 2. Okay, and so if I do that, I'm able to find the derivative of what? The sine function. Okay, I'm going to leave you to do the cosine function. That is, if you have what is, if f of x or f of x is equal to cosine of x. Now, its derivative of x is what? It's actually negative for sine x. Okay, so you are going to try this one. So I want you to try this. Okay, try that. Okay, to prove that the derivative of the cosine function is equal to what? Negative sine of the angle. Okay, so here's an example. I actually have that over somewhere. I've got put it here. Let's try this, give this a try. So I have it right here. Okay, but let's take a sample. Now we have other higher order of what? Derivative. Suppose we are given this function that find the given derivative. Let's say find the derivative by finding the first few derivatives and observe the pattern that occurs. So if I have derivative of 99, it means I have to differentiate what 99 times. It doesn't make sense to do that. Okay, that is why we have come this far. Now, what we're going to see if there is any pattern that we can observe, and then we're going to generalize it. Okay, so first we know how to differentiate what derivative of a sine function. Okay, so once we know that derivative, guess what? Then it makes life easier. So first, let's do what's the first derivative? That is d dx of sine. Okay, now let's call this. Let me call my f of x is what? Is sine x. Okay, let's call that. So what is my f prime of x? F prime of x is what? Cosine of what x. What is f prime prime of x? Okay, if I differentiate cosine of x, I get negative 4 sine x. Okay, remember I just showed you it's negative x. Now, if I go to find the differentiate that again, that is the third derivative. Okay, if you differentiate, you have minus, and if you differentiate sine, you get what? Cosine. So that will be negative of what? Cosine of x. Then if you differentiate the fourth time, that is I p, or you can call this what? F of what? 4 in parentheses. Okay, this is equal to your minus, and if you differentiate cosine, you have minus what? Sine x. Now, if you put this together, you have what to be sine what? Sine x. Now, let's see something here. Okay, do you see a pattern? We started with what? Sine, and then look at where it is repeating. Okay, so it means that the pattern is that whenever you have for what do you call it, the multiples of 4, then the function repeats, right? If I keep doing this, continue and find to the f of 8, this will be equal to what? Also sine what? Sine x. Okay, so the pattern is this. The pattern is that if you have f of that n, it is equal to sine what? X, if n is a multiple of 6. Sorry, if n is a multiple of what? 4. So if I have 99, okay, if I have 99, I want to find a multiple of a number closest to what? 99, but less than that. Okay, instead of differentiating this 99 times, which is a lot of work. Well, I know that it's what? 96. Okay, so it means that if I differentiate the word 96 times, it will be what? Sine of x. Okay, now if you have sine of x, then I can go 97, 98, 99, I'll get my answer. Because this is the case, because 96 divided by what? 4 is what? Is equal to 24. Okay, so then it means that what is f of what? 97 of the sine, that will be what? Cosine. Okay, that is cosine, just like we did here. Then f of what? 98 of the function be minus what? Minus sine what? Because if you differentiate cosine, get negative. Then f of what? 99 x is equal to minus of what? Cosine. of x. So we have found our answer, 99 divided by dx 99 of the function sine x is equal to minus cosine x. Okay, so that should be it for that question. You don't need to differentiate the 99 times. You leave few of them, look for a path, and then generalize. Okay, all right, this is what I wanted to, we will use this. So differentiate the cosine, you get what? Negative of sine. I want to find the proof of that. So I want to prove this. Okay, prove that. Okay. Now, the derivative of a tangent, since I know how to do the quotient rule, and I know the derivative of sine and cosine, I can use that to prove the derivative of what? Tangent, and find what it is, okay? Because tangent is what? Sine over cosine, okay? Sine over cosine, so I can use a quotient rule on this. So therefore, let's try that, okay? The derivative of the tangent, okay, of the tangent function, this is equal to, say, keep the what? The bottom, and differentiate sine minus, now keep sine and differentiate cosine, and then divided by square of what? Of the cosine function. Okay, so let's do that. This is cosine of x. Differentiate sine, you get what? You get cosine. Minus, you have sine of x. To differentiate cosine, you get negative sine of x. And then cosine squared is the same as cosine, that you can write that instead of cosine x all squared is the same as that. Okay, so let's simplify that. Cosine times cosine is what? Cosine squared. Then negative times negative is plus what? Sine what? Squared of x divided by cosine of squared of what? X. But we know that one of the identities, cosine squared of x plus sine squared of x is equal to 1. So the numerator here is 1, and then over what? Cosine squared of x. Now we know that what is 1 over sine? So 1 over cosine. 1 over cosine is what? Secant what? Secant of what? X. And so if you have 1 over cosine squared, that is the same as what? The secant what? Squared of x. So in other words, if I differentiate tangent, I get what? Secant squared of that. Okay. You can use it to find what? Cotangent. Cotangent to, cotangent is the derivative of cotangent is the same as the derivative of what? Cosine over what? Sine. So you can do the same similar thing and then see what that is. All right. Okay. So if you do, it's the basic trig functions, the 6 of them. If you differentiate, we did this one. Derivative of sine is cosine. The derivative of cosine is negative of sine. Tangent is secant squared. And then cosecant will be negative cosecant times what? Cotangent. And the secant will be secant times what? Tangent. And then cotangent will be what's negative cosecant squared of x. Okay. Now this is a must know. All right. It's a must know. You must know them, because if I ask you to just write them down and use it, once you know them, it's going to help you in what? The rest of the class, and then what? And Calc 1, and if you are taking, sorry, Calc 2 and Calc 3, if you are taking all those classes. All right, very good. Now, let's differentiate other examples. Take other examples. Look at, it said we have a given f of x as that. Okay, now if I look at this expression here on the right, look at this, the first term It is x times cosine of x. That tells me I must use the product rule on that. Okay. So what's the derivative of what? The f. So f prime of x is equal to, okay, the derivative of x cosine x plus the derivative of what? 2 sine x. Okay. Now we're going to use the product rule on this one. Okay. Use the product rule. Okay. So that gives me, is a keep the first one x and then differentiate what? Cosine of x. That will give you minus sine x plus you keep cosine of x and then differentiate x will just be what? 1. Then plus, if you differentiate 2 of that, you can bring the 2 out times the derivative of what? Sine x. Okay, so this gives me minus x sine x plus cosine of x. Then if you differentiate this, the sine, we get what? Cosine. That'll be 2 times that will be 2 cosine what? Cosine x. Well, if we add in cosine and cosine, that's one of them. So this is minus sine x plus 3 cosine of what? Cosine of x. And that is my first derivative. I can find the second derivative and the third and so on and so forth. But this is the what? You got to do it. That is why. That's the first derivative. Okay. Now, let's look at that. All right, so you see, this is a numerator and denominator. So what comes to mind? The quotient rule comes to mind immediately. Okay, quotient rule comes to mind immediately. So let's use the quotient rule and then simplify that. So we have f prime of what? Theta. We are using the quotient rule, keep the numerator, sorry, the denominator, which is 1 plus cosine of theta. Then multiply by the derivative of the sine. Sine theta minus, keep the word sine theta, multiply by the derivative of the denominator, which is cosine of theta, divided by 1 plus the square of the word, the denominator. Okay. So that gives us, the next step will be 1 plus cosine of theta. If you differentiate sine, you get what? Cosine of that. Minus the sine theta. If you differentiate 1, you get 0. If you differentiate cosine, you get minus. So that will be minus what? Sine theta. Now, all divided by 1 plus cosine of theta minus what? All square. I was tempted to write the word x because I'm writing that so frequently that it becomes generic. Okay. Now, let's multiply this out. So this is equal to cosine times 1 is what? Cosine of theta. Then cosine times cosine is what? Cosine squared. Right? And then again, minus sine theta times minus will be plus sine what? Sine squared theta. Then divided by 1 plus cosine theta, all what? All squared. And so what did that give me? Now look at the numerator. Cosine squared plus sine squared is what? 1. That is a trig identity. So the numerator is cosine of theta plus 1 divided by 1 plus cosine theta all squared. Now I want to see that 1 plus cosine theta is the same as cosine plus 1. So the whole thing is that the first, this will cancel 1 of them. So the answer is 1 over 1 plus cosine theta. That is your answer. Okay. All right. So that's another example. Now, This is where I wanted to pay attention when it comes to using the limits, all right, using these identities, okay, which we have stated before, that if you have x goes to 0 of sine of the angle divided by x is equal to 1, and then x over sine of x is also equal to 1. So we're going to use it to prove that, to find the limits. What does that equal? Okay. Now we can do that by making sure that, see, this is a sine of what? F of 5x. The denominator too must be what? 5x. So this is, if I have this case, the limit s goes to 0 of what? Sine 5x divided by what? 5x, then this should be equal to 1. So that's my goal, to achieve something like that. But I have 3x, so that means I need to manipulate this expression there. So that will give me the limit x goes towards 0. Then the 3x down there, I'm going to write it as 1 over 3 times sine 5x over what? Over x. So now, if I multiply, if I divide by what? 5 here, then I need to also multiply by what? 5. So that I have my sine what? Sine 5x divided by 5x, which will be equal to 1. Okay. So look at how we do that. See? So I have my 1 over 3 there. Guess what? So what we have there is basically the limit. X goes towards 0. Then 5 over what? 3 times sine 5x over what? 5x. Okay. So this 3 over 5x, 5 over 3 is not dependent on x, so I can put it as a constant. So you can rewrite this as what? 5 over 3 times the limit x goes to 0 of what? Sine 5x over what? 5x. That goes to 1. So this is basically 5 over 3 times 1, which is what? 5 over 1. Okay. Now, this guy here is interesting. We need to be able to manipulate that very well, otherwise we may get it all wrong, okay? I think there's a typo there. Okay, so this must be, it must be this must be tangent of that. I cross-check with the question and I realized that's something wrong there, okay? So this is actually, let's write it here. This is what the limit, when find t goes towards 0, tangent of 6t over what? The sine of what? 2t. Okay, so we're going to write this as what? The limit, okay, t goes towards 0. We're going to split that, okay? I have my 1 over sine 2t and then times what? Tangent of what? 6t. Now notice that it is the same, okay? Now, it's the same thing. This is over 1, okay? That's the same expression there. Now, I know that tangent is what? Sine over what? Cosine, okay? So let's introduce that. So this is equal to the limit t goes to 0, 1 over sine 2t, then times, okay, sine 60 over what? Cosine what? 60. All right. Then I can write this this as what? 1 over cosine t times sine. Well, sine 60 divided by what? Times 1 over cosine of 60. So let's rewrite and see what I'm trying to say. So t goes to 0, 1 over sine 2t times sine 60, then times this over 1 times 1 over what? Cosine of what? 60. All right. Now, if I'll be able to use these properties that are written up here. Okay, the denominator here must be what? Okay, the numerator here must be 2t, and the denominator here must be 60. So what I'm going to do is that I'm going to introduce t. I'm going to multiply the whole expression by t over t, which is 1, right? Okay, so I'm going to change the color. I'll write what this. I'm going to put it instead of 1. I'll put a t here, and I put a t there. Because the t times divided by t is 1. Okay, but since I can use this property, say this is 1x and 1x. If x goes to 0, that's equal to 1. So since that is what? 2t. If I multiply this by t and they also divided by what? Divided by 2. That will work, right? Now if I multiply this by 6, divided by 6, and also multiply by 6. So that I have sine 60 over what? 60, like that. And that also will simplify it because the 6 will cancel out, the t's will cancel, and the 2's will also cancel. So then that expression there is nothing but, okay, this is equal to the limit. T goes towards 0, and I have 1 over 2 times 2t over sine 2t. I have 6 times sine 60 over what? Then 6 what? 60. Then times 1 over cosine of what? 60. Okay. Now the limits will go each of them. Right. This is outside, so I can write this as 1 over 2 times the limit. T goes to 0 of what? 2t over sine 2t. Then I have for 6 times the limit sine 60 over 60. T goes to 0, and then times the limit t goes to 0 of what? 1 over cosine of what? 60. Okay. Now, with the properties that we have talked about, okay, what happens that this goes to what? This goes to 1. Okay, this whole thing also goes to 1. And then 1 over cosine of 0 is 1. So this guy is nothing but what? This part is what? 1 over 1, which is what? Which is 1. So your answer is going to be 1/2 times 1 plus, okay, 6 times 1 plus, sorry, times, not plus, actually, it's times. Okay. Okay. So the answer is going to be this. Will be equal to 1/2 times what? 6 times 1, which will give us what? Will give us 3. Okay. It's patient, and you need to be careful using that word, that property. Very, very important. These 2 properties we have. Okay. All right. Now here is an application. That's the last example that we want to do. And trigonometric functions are often used in modeling real-world phenomena. Okay, in particular, vibrations and waves and elastic motions and other quantities that vary in periodic manner can be described using trigonometric functions. And if you want to know the rate at which things are changing, then of course that's what this section is very important. You see that in lights, in physics and waves and lights and motions and everywhere, and trajectories and all that. Okay, so here's a question, exercise number 37. It said a ladder, I think I have a more specific, a ladder 10 feet long rests against a vertical wall. Okay, let theta be the angle between the top of the ladder and the wall, and let x be the distance from the bottom of the ladder to the wall. Okay, if the bottom of the ladder is slice away from the wall, how fast I want you to know that. How fast here, okay, how fast is not time. Okay, how fast does x change with respect to theta when the angle is what? Is pi by 3. Okay, so I'm going to draw a diagram so that you can see. Let's go to the next page, get it more, get it. Next page to get the space, more space there. Okay, we're going to draw a diagram. Okay, so here's my ladder. Okay, okay, and then that's my wall. I mean, and that's my ladder. Okay. So that's my ladder. It says that we should let the angle between the wall and then the ladder from the top of what be theta. And then x is the distance. This is what the ladder is moving away from what? From that. Now, if you go back to the question, it said the ladder is how long? It's what? 10 feet long. That length doesn't change, all right? The length doesn't change. So it means that this is what? This is what? 10 feet. Okay. So if this is sliding away, this is also what? Coming down. So it means that there is a change of that distance, this distance, x, with respect to what? The angle will, what do you think? If this is coming down, what happens to the angle theta? Okay, if it's coming down, it gets what? Bigger and bigger and bigger. All right, but this angle here gets smaller and smaller. Very good. So then, what's the relationship? So we have to find a formula. What's the relationship? Okay, the relation between x and what? Theta, the angle. Okay, and that gives us the function. Now, according to the question, we should find what? Okay, how fast does what x change with respect to what? That's a rate. Okay, so we need what? Dx, d theta. Now, before I can find, I need to know the relationship between a formula in x in terms of theta, so that I can differentiate that with respect to what? With respect to x. Okay, so this is the how fast. How fast. Okay, that's what we need. And then we are given that the angle is what? Pi by what? By 3. Very good. So what's the relationship between these two? This is a right triangle. You know the hypotenuse, which is the 10 feet. So what's the relation between x and that? Okay, sine of the angle is equal to opposite of the hypotenuse. Okay, so we're going to use the saw. Okay, we have car and tool. Excuse me, we'll use a socket tool. So the sine of the angle is equal to the opposite x over what? Over the hypotenuse, which is 10. So it means that x is equal to what? 10 times what? Sine of what? Of the angle. So now the x is a function of theta, which is what? 10 sine of what? Theta. Okay. Now the rate, which is what? Dx with respect to what? The angle, which we are looking for, which is here, how fast. So this is the what? How fast. Okay. If you differentiate this, you have 10 times what? Cosine of what? Of the angle of theta. Okay. So then when the angle is what? Pi by 3. What is this equal to? This is 10 times cosine of pi by 3. Now, cosine of pi by 3 is what? Is 1/2. Okay, so this is equal to 10 times 1/2. And that is what? This is 5. Okay, so what is the rate? Is the rate has a unit. X is in feet. And then that is what? Angle is what? In radians. Okay. So this is going to be 5 feet per what? Unit radius. And that will be our what? Okay. Now that we're going to apply this, in fact, when we get to chapter 4, it'll be applications of trigonometry. So we're going to see real life phenomena where we'll be applying all the rules that we have learned from chapter 3 and maybe chapter 2 and when we get there. Okay. So that brings me to the end of this section, and I'll see you next time.